Today we are starting our new unit, which is talking about energy. So the first thing we should ask is what energy is. Now we're going to give you a general definition. Energy is the ability to cause change. In other words, if you don't have energy, an object does not have energy, it cannot change or affect its environment. And directly related to that is the law of conservation of energy. This is actually a very important statement, one of the most powerful ones in physics. And it states that energy cannot be created nor destroyed, but energy can be converted from one type of energy into another. So in the example you see here, we have the solar energy coming from the sun, so the light energy hitting the trees convert the energy through photosynthesis into chemical energy, and then through other chemical processes it is converted into coal over years and years. That coal is then harvested and burned, releasing heat energy, thermal energy, and that is converted into electrical energy that helps power the power plant and send the electricity to your house. During all those processes, no heat was actually used up or lost. It was just converted from one type of energy into another. So we're going to discuss 9 main types of energy: gravitational potential, kinetic, elastic potential, sound, electrical, light, thermal, chemical potential, and electrical. So we're going to go ahead and go through those in order. But before we do, we want to go ahead and make a quick note about potential energy. Any of the energy types that are listed as potential energy are basically stored energy. This means you can't actually see that energy. What can happen though is when that energy is converted to another type, like the law of conservation says can happen, then we can see that potential energy released as a different type. In the example that you see here in the picture, first type of energy we're going to talk about is gravitational energy, the energy due to height. When you hold an object above the floor, you don't see its energy. But when you let it go, that gravitational energy is converted into kinetic, a type of energy you can see. So again, potential energies cannot be seen, but they can be converted into types that you can see. So we just discussed gravitational potential energy. The energy an object has due to its height above the ground and the mass of the object. If you want to give an object more gravitational energy, the easiest thing to do is simply to raise it up. Make sure that you know what gravitational potential energy is and what it depends on. It is one of the main 2 types of energy we're really going to focus on. So again, gravitational potential energy depends on the mass, but mainly what we're going to be discussing changing is the height. The higher the object, the more gravitational energy it has to turn into kinetic energy as it falls. And as we talk about kinetic energy, that's our second one. Kinetic energy is commonly called speed energy, the energy of motion for the object. So the faster an object travels, the more kinetic energy it has. You know that if you hit a wall at a slow speed, it may not hurt that much, but you hit the wall at a fast speed, you notice an increase in how much pain you feel. You have to dissipate more kinetic energy the faster you're moving. Elastic potential energy is the energy an object has due to being stretched or deformed. So in this example at the top, you see a bow and arrow. When you stretch the bow, you put elastic potential energy into it. You don't see that energy. You see it stretched, but you don't see any energy. But when that elastic potential energy is released, usually it's going to be released as kinetic energy, and so you see that energy of motion, the energy that it gets due to its increase in speed when the elastic potential energy is converted into kinetic. And here's a fairly extreme example of elastic to kinetic energy taken off a TV show where they were doing a competition. This woman is launching melons, and she's got basically what amounts to a giant slingshot, and something went wrong. I can't even figure out what. But after she released it, it held onto the melon and actually launched it back. And if you watch closely, through a really bad coincidence, she ends up getting hit directly in the face with that watermelon at a high speed. All that elastic energy was converted into kinetic energy and caused quite an impact directly into her face. The fourth type of energy we're going to discuss is sound energy, which obviously you're very familiar with. But what you may not know is where sound energy comes from. Sound energy is actually caused by vibrating objects. So as objects move, they push the air. As an example, when I'm speaking into the camera right now, my voice box is vibrating, and those vibrations push on the air molecules, which push on other air molecules, and those vibrations travel until they hit, if we're in class, your eardrums, or in the case of this video, the microphone, which converts it into other types of energy. So sound energy could be considered a type of kinetic energy, since it really is a type of moving. As the sound wave moves through, it causes the particles to vibrate. We're not going to focus on that little fact very much, but I do want you to know that sound energy is caused by vibrations traveling through objects. Another type of energy that you're familiar with is electrical energy. Electrical energy is basically the movement of electrical charge, which can be either positive or negative. One of the reasons why electricity is your main form of energy that we use is because of all these different types of energy. Electricity is pretty much the one that's the easiest to control, to move from place to place in the amount that you want, to shut on or off as you need, and as soon as you turn it on, you have instant access, it flows. Due to that reason, instead of using all these other types of energy to transmit the energy from place to place, electricity is our preferred type. The next form of energy we want to discuss is light energy. Now, when you think about light energy, you think about the light that you can see, but it turns out that there's many different frequencies of light that your eyes are not capable of detecting, but are actually out there. So light is actually more than just the light that you can see. It's actually the different frequencies of light that are beyond the human range of vision. So some examples of light that you can't see with your eyes but can be detected through other means: radio waves, infrared light, ultraviolet light, gamma rays, microwaves, x-rays. Those are all just different frequencies of light. Light, visibly, we usually call it light, but if we talk about all those different frequencies of light, commonly that's called electromagnetic radiation. The seventh type of energy we want to discuss is thermal energy. Thermal energy essentially can be thought of as heat, but there is a slight difference. Thermal energy is the energy contained in an object. Some people call it internal energy, and that causes the molecules to vibrate. Now, the warmer an object is, the more thermal energy it has, the faster those molecules will vibrate. And as the object cools off and lowers its temperature, the vibration of those molecules that represent the thermal energy, those vibrations get slower. Theoretically, there's a temperature called absolute zero that we will probably never actually be able to reach fully, but at absolute zero, that will be where all the thermal energy leaves, so the vibrations of the molecules actually stop. Now, the difference between thermal energy and heat is actually considered the flow of energy, thermal energy, from place to place or from object to object. But we're not going to make too big of a distinction. If you want to call thermal energy heat for the purposes of our class, that's going to be just fine. The next type of energy we're discussing is chemical potential energy. Now, there's a lot of examples for this one because there's a lot of different places that you find it that I feel that you should know. But basically, chemical potential energy, it's stored in the chemical bonds of molecules. Now, last semester during the chemistry section, we learned about the different chemical bonds. We talked about some different types, but as atoms join together, they form chemical bonds in order to make molecules, and those bonds hold chemical energy. Again, since it's a potential energy, you cannot see the energy actually, but it can be released as other types. So let's take a look at a few different sources here. The first source for chemical potential energy I like to discuss is photosynthesis. Photosynthesis basically takes light energy, and through a chemical reaction, it creates chemical bonds that create sugars and oxygen. So here in the example, as the light comes in, the chlorophyll allows it to turn the light energy into what says carbohydrates and oxygen. One of the types of carbohydrates would be glucose, which is a type of sugar that you should have learned about in biology class. So photosynthesis allows carbon dioxide and water to break apart gives it enough energy to form new bonds, glucose, a carbohydrate, and pure oxygen. We eat the plants partly because there's more energy stored in the glucose when these molecules are stored like this than they are when they're separate. So when we eat those sugars from plants, we break those molecules apart when we digest them, and that releases energy to help our body run. Another type of still chemical potential energy is combustion, which is basically fire. And so any flammable object, gasoline, wood, kerosene, burning plastics, hair, they all release the chemical energy as in another form when they burn. Typically, when you think about something being on fire, the energy is going to be released as light energy and thermal energy. So anytime an object is on fire, you should know that it had chemical potential energy and it's converting it into thermal energy and light. Another type of chemical potential energy is in batteries. So batteries have chemicals inside them, and when you connect one end of the battery to the other side of the battery, the chemical reaction starts to take place, and what that does is it moves electrons, electrical charges, from one end of the battery to the other. So batteries run off of chemical energy and convert it into electrical. And we've already discussed this a little bit, but food, hamburgers, hot dogs, bread, anything that you eat and consume and digest has chemical energy stored in the molecules in the food. As our body digests that, it breaks the bonds that hold those molecules together, which releases energy in the body, and your body can use that energy to form different chemicals to help keep your body running. And so the last thing we're going to talk about with chemical potential energy is your body itself. As we just discussed, when you eat, your body digests that food. In biology class, you had talked about ATP, which is a type of molecule that allows energy to be transported from one place to another. And what does that do? That allows your body to continue not only to function, but you can use that energy that you get from food in order to perform exercise. So you think about times where you've worked very, very hard physically, and at the end of the day you tend to be hungrier than usual because that energy has to come from somewhere. It comes from the food that you eat. And so when you exert yourself, you have strenuous exercise, you use more of your body's energy, and you have to replace that by eating more food. The last type of energy we want to discuss is nuclear potential energy. Now this is probably the type of energy that of all of these that you're going to be least familiar with. We probably won't get too far into anything, but I do want you to know a few basic examples of nuclear potential energy. Nuclear potential energy is stored in the nucleus of atoms, and that's where the word nuclear energy comes from. The nucleus, the center of the atom, where the protons and the neutrons are. And that happens to contain much, much more energy than you get from a chemical reaction. And so examples of nuclear energy include atomic bombs, nuclear power plants. A big thing that's going to come up repeatedly that you do want to remember is that the sun, it's not on fire. It's not a chemical reaction. It is a nuclear reaction. It's just so hot that it's glowing, but there's no actual fire in the sun. And then finally, anytime you hear about radiation, radioactive materials, that is actually the release of nuclear potential energy, as the atom might be able to break apart, and when it does so, it releases energy. The nuclear energy gets converted into other types. We want to talk about energy conversion. So here we see a track runner. He's coming up. He's actually pole vaulting, and so we see some conversions from one type of energy into another, and then into another. So as we run this animation again, he's running, so he has a lot of kinetic energy to his motion. But the kinetic energy is converted into elastic as the pole bends, and then he gains height, so he gains gravitational. And then as he falls back down, he gains kinetic energy as the gravitational turns from height, turns into the kinetic from speed as he falls. Now you can pause and watch the video again, as you can see the little bar graphs right here going from one type to another, but we do want to discuss different types of energy conversions. So let's see how well you've learned. Let's take a look at some of these different examples and discuss what kind of energy conversions we have going on here. We want to know what type of energy does the situation start with, and what type of energy is it being converted into. So for this first example with the boy riding the bike, he's being powered by his own body. And what does your body run off of? It runs off of kinetic energy. And when you're riding your bike, what are you doing? You're making yourself move, you're making yourself go. So in this case, we have chemical energy being converted into kinetic energy. In the next example, these gentlemen are going to be flying out of an airplane. They're parachuting. And so they're falling from the sky. What kind of energy do they start with? At the top of their fall, due to the height, they have gravitational energy. Remember, we said it's very important to remember gravitational energy depends on the height of the object. But what happens as they fall? They lose height, they lose gravitational energy. Where did it go? Well, as they fall, they also gain speed. The gravitational energy is being turned into kinetic energy. And then down here, we just talked about the last slide or two, we talked about the sun. So what kind of energy does the sun run off of? We said it runs off nuclear energy. And what are the two main types of energy that the sun turns that nuclear potential energy into? It mainly turns it into thermal energy, heat energy, and into light energy. Here from The Office, we've got Andy doing a little dance. And so again, this is one of those chemical situations. Your body runs off of chemical energy. So what is he using this chemical energy to do? He's converting it into motion. So again, this is an example of chemical energy being converted into kinetic energy. And for our last example, we've got the space shuttle taking off. Now this one actually has quite a few different types of energy. So if we talk about them, what kind of energy does it start with? Well, what's this shuttle run off of? It runs off of fuel. And fuel always has chemical energy. So it starts with chemical energy. What's it converted into? Well, we see a lot of flames here. So what are the flames? Flames are going to be a lot of heat and a lot of light. We also know that the shuttle rises up, so it gains height. That's going to be gravitational energy. Not only does it rise up, it also gains speed, so it's gaining kinetic energy. And then finally, as it does all of that, if you've probably never been to a shuttle launch, but if you ever talk to anybody who has, they say that the noise is just deafening. There's a huge amount of sound energy created as well. So again, I want you to be prepared to be able to do energy conversions. Take a look at the situations and say, it starts out with this type of energy and it's converting it into this type of energy. And in some situations, you might have more than one type of conversion. And then finally, we do want to make a note here talking about the fact that during any energy conversion, some energy is going to be wasted as thermal energy. So if you've ever wondered about why do you have a body temperature? Well, as your body digests the food, it does those chemical conversions, converting the chemical energy from your food as it digests it, and it uses that to create new chemicals, and your body continues to use that ATP chemical energy. Not all of the energy is converted to energy to make your body run. Some of the energy that you got out of the chemicals is released as heat energy, thermal energy. And so that's why you have a body temperature. These chemical reactions, as you see in this thermal image here, a lot of your body's chemical energy that it got from digesting the food, a fair amount of that energy is wasted as heat energy. A situation right here where you slide. If you've ever slid and you weren't wearing pants, or even if you were wearing pants but it was a pretty big slide, you may have noticed, really caused some damage, really caused some burning. Kinetic energy, when you slide, kinetic energy can be turned into thermal energy. When you rub your hands together, when you're cold, when you go like this in the wintertime, what's happening there? You're turning your kinetic energy into thermal energy through the force of friction. So the energy is being converted, some of it in any energy conversions going to be wasted as thermal energy. And then something else you're very familiar with, especially right now where you're probably spending a lot of time using your screen, is what happens when you have electronics. Well, when you use the electronics, they're running off of electrical energy, and not all of that electrical energy goes into running the object. Some of the electrical energy, as it travels through the wires, is wasted as heat energy. In the background, you might be able to hear the fans of my computer running because some of the electrical energy running the computer is wasted as heat, and that heat needs to be taken out of the system before it damages the components. Batteries, when your cell phone, it's not just the electricity running through the wires that makes it hot, but the converting the chemical energy from the batteries into the electricity causes the battery to get hot as well. So that's our discussion here about different types of chemical energies and their conversions. Next class we're going to be focusing specifically on the equations for solving gravitational energy and kinetic energy. So be prepared to take a look at some formulas and to be able to solve some problems for those two different types of energy.